So, first lecture. We're going to talk about sleep, which is kind of fitting this early in the day. I think in many ways sleep is fascinating, mainly because we don't really know why we sleep and what good it does. The fact is that it seems as if basically all animals, including insects, actually sleep. So it seems to be a property which is closely related to being an animal. For quite a long time it was thought that some mammals, including dolphins, didn't sleep, but it turns out that they actually do sleep, but they have a system so that they can stay awake on one side of the body, whereas the other side of the body is going to sleep. So each hemisphere of the brain can thank you, can sleep separately from the other hemisphere. So basically, when the dolphin is swimming around, one side of the body basically goes paralyzed during the sleep, and that goes on for some time, and then it switches over so that the other side of the brain goes to sleep and the other side of the body is paralyzed. So that's the way that the dolphin manages to sort of stay awake and asleep at the same time. So there seems to be some kind of necessity of sleep. And that's also clear when looking at what the effects of lack of sleep actually are. So these are just some of the doesn't it become more and more screw? Anyway, so what you will experience following lack of sleep, and of course here it's a question of what lack of sleep is. For how long do you have to not sleep in order to experience these effects significantly? I think for the first two ones here, reduced attention and increased reaction time, all it takes basically is one night of not sleeping sufficiently well. On average, this would mean that you would sleep less than 5 hours during the night. If you get up in the morning, you will have measurable changes in your ability to pay attention to what is being said during classes, as well as having a significantly increased attention time. The order of magnitude is similar to what you see after drinking alcohol. So it's roughly equivalent to basically 0.5 promille alcohol consumption. Reduced memory, reduced cognitive abilities, reduced motor abilities, etc. are sort of similar things. It's all about how the brain responds to sensory incoming input and the motor abilities as a consequence of that. In addition to that, there are also measurable physiological effects, especially the immune response, glucose tolerance, and in general increased fatigue that you can measure physiologically. These are of course all because the brain is important in regulating both the immune response and reducing the response to glucose, etc. It has been found that rats die within just 1 week if they're prevented from sleeping. It's not as bad in humans, but definitely if you do not sleep for a longer time, you may end up dead. The only thing there is that most people will then fall asleep sooner or later, and therefore presumably not die. The tricky thing here about rats is that you can actually keep them awake. So basically, when do we experience lack of sleep? It varies individually, and some will argue that they need at least 9 or 10 hours, and others will say that they get along quite well with just 6 hours of sleep per night, or even less in some cases. So there is a huge variability The longest recorded time without sleep documented is 18 days, 21 hours and 40 minutes, which I believe is still the standing world record. It's not a sensible thing to try and do and try and stay awake for this long. You develop all sorts of symptoms which are not all that nice. After 2 to 3 days without sleep, most people will develop hallucinations, paranoia, various visual problems, memory problems, lack of attention, speaking problems, etc. So it's definitely signs of the brain not liking to be kept awake for this long. Definitely there's also a catch-up. So people who have attempted to stay awake for this long have to catch up afterwards, so they tend to sleep for a very, very long time, for maybe the next week or so in order to catch up. And luckily, also in those cases, all these nasty symptoms tend to disappear. So there are no recorded cases where people have actually become insane as such from trying to stay awake for a prolonged period of time. Once you get the chance to go back to sleep, then things normally turn out to the better. There are examples, but this is unusual, of subjects who fail to sleep whatsoever. And this is normally because of some lesion in the brain or some genetic disorder which destroys some of the sleep-inducing mechanisms. And these people normally die at some point, having lots of hallucinations, being basically going insane. The reason why they're dying is a little bit unclear. It's not certain that it is because of the lack of sleep. It may also be because of the underlying disorder which has led to these sleep disorders. So in any case, it is clear that the reason why we sleep is usually in order to not get all of those symptoms. So basically, it's the brain that needs us to go to sleep in order for it to function optimally. But we don't really know what good sleep then does for the brain, except avoid all of these symptoms. So yeah, it's blank. That was just to point it out that we don't really know. But anyway, getting a little bit closer to what it is that makes us go to sleep, it's quite obvious that sleep is tightly linked also to general biological rhythms, and some of the rhythms that we have in our brain, in our body, are also linked to the sleep-waking cycle that we have. So definitely there are changes during the day, during the night, in obviously alertness. When we go to sleep, we tend to be less alert than when we are awake. Temperature changes quite dramatically. When we sleep, it goes down, goes up just prior to waking up, and then it stays quite high when we're awake. This is not only because we become physically active, it's also if we just lie in the bed without moving, then the temperature will go up anyway. So it's regulated in the brain, in the thalamus, in the hypothalamus. Growth hormone secreted from the hypophysis is also increasing just around the time that we go to sleep during the night. Cortisol increases early in the morning, just prior to when we wake up. Even potassium is changing throughout the day according to when we're asleep and when we're awake. So there is an internal clock, and many of these things are linked together in the whole body's rhythm during